In this video, this is the geometry section 8.4 and the start of 8.5. We're going to be doing inverse trig and right triangle application notes. So in this lesson, we'll be solving for missing angles of right triangles using trigonometric ratios. We will solve a triangle for any or all missing parts, and we'll develop your problem-solving skills throughout by interpreting word problems. Your calculator can do two types of operations with trig. They can do the sine of A, or cosine or tangent, whatever, and give it to you as a decimal. Or you can do the inverse operation. Okay, and most calculators is the second button and then the sine button. You should see it. It says it's got a power of -1. It's a decimal, and that's going to find a missing angle measure. So the regular sine finds the missing sides, and inverse finds missing angles. So we're going to use our calculator to approximate values to the hundredths position, and that once again is to 2 decimal places. Okay, so let's get our calculator out and follow along and do that now. Alright, so make sure it is in degree mode again. Okay, if it's not set up, you could see it under mode here. Click under degree. So we just do tangent 22. That means we'd be finding a side length part using a decimal. So our calculator gave us 0.40. If we did sine 34, looks like 0.56. And if we did cosine 79, 0.19. Find the missing angle measure. So the other skill you need to do is you need to be able to hit second tangent. So tangent to the -1, so that inverse is what it's referring to. You put the 28.6363, enter, and we go to the 10th degree. In this case, this would be 88 degrees. Next one, we got the inverse sine of 0.1045, and it looks like it rounds up to 6 degrees. And lastly, we're looking at the inverse cosine of 0.9336, and that looks like that's rounding up to 21 degrees the way it's rounded. Okay, so depending on, we got a couple more to do here. We have the inverse tangent of 1.1504. Looks like 49.1 degrees. Next one, we have inverse sine of 0.9511, giving you, looks like 72 degrees. And lastly, the inverse cosine of 0.6691, which looks like it's exactly 48 degrees. Okay, make sure you're using the right operation when what you're solving for. Okay, so it looks like rule of thumb on this is that 2 decimal places for side length and to the nearest tenth for a degree for an angle. So in example 1, we're looking for a degree for an angle. You're going to mark your sides. So like you should think right now, oh, I'm going to do the inverse. Like that should come into play. I'm looking for an angle, so I need to do the inverse button. Mark up your O, A, and your H. So across is your O. Hypotenuse is across from the 90-degree angle. That means this is the A. So if you remember from our last unit, so TOA, you got the sine, O and H, cosine, A and H, tangent, O and A. Okay, so we have the O and the A is where the 6 and the 15 are marked. So what looks like we're doing the sine of x is equal to 6 over 15. This is where you would go to your calculator, get the inverse sine, 6 divided by 15, put it in parentheses, please. So we hit inverse sine of 6 divided by 15, close the parentheses, and we get approximately 23.6 degrees. The degree marker needs to be there because we're looking at degrees. Second one, once again, we're looking for an angle measure, so we'll do an inverse. Opposite side is the here. Oops, put an A, geez. Opposite side is the 400. The H is here, A is here, so we don't have the H, we have the O and the A tangent, so we're doing tangent of x is equal to 400 over 300. So your calculation would be an inverse tan of 400 divided by 300. For your calculator, inverse tan 400 divided by 300, enter 53.1 degrees. Okay. Next example, it looks like we are trying to find two angle measures and a side length. So let's choose a letter that we want to start with. So if we chose A here, so from A, the opposite side is 7. The hypotenuse is x, and the 24 is the A. So if we're trying to find the measure of angle A, so we have got the O and the A, so we'll do the tangent of angle A is equal to 7 over 24. What that means, you do the inverse tangent, 7 divided by 24 in parentheses. So inverse tangent, 7 divided by 24. 16.3 degrees. Now we can do the same thing and try and find B. Or you remembered that how many degrees are in a triangle? You said 180 degrees are in a triangle. You are correct. So we know that for angle B, we can take 180 minus 90, because that's the right angle, and then minus 16.3, and that's going to give us the answer that we want. 180 minus 90 minus 16.3. That would give us that this angle measure is 73.3 degrees. If not, you can set it up and do your trig function from there and solve. What would you do to find the missing side length? So we're given two sides, and you want to find the third side, which is missing as well. Did you say Pythagorean Theorem? Nice. So Pythagorean Theorem, where you can set up a squared and b squared equals the hypotenuse, which is c squared. So we got 7 squared plus 24 squared equals x squared. 49 plus 24 squared 576 equals x squared. Add them up, get 625. And if you remember from your list when you root it, your answer is 25. Why don't you try pausing the video and try number 4 on your own and see how well you did for it. So good luck. Pause it and see if you can mirror image what we just did for number 3. Alright, so let's go with angle A again. Opposite side would be 6. H is the hypotenuse, which means x is the A side. If you want to find the measure of angle A, we're looking at the O and the H, so that's the sine. So we're going to be doing sine of the measure of angle A, that's what's missing, is equal to 6 over 9. With inverse sine, 6 divided by 9, go to your calculator. Inverse sine, 6 divided by 9, bingo, 41.8 degrees. Then you can take your calculator and take 180 minus 90 minus 41.8 and end up with 48.2 degrees for the measure of angle B. For the missing side length of x over here, Pythagorean Theorem, we could do 6 squared plus x squared equals 9 squared. So the longest side, the hypotenuse, has to go over here. 36 plus x squared equals 81 minus 36. We get x squared is equal to 45. And then we can break up our root from there. We get root 9 and root 5, so that's 3 root 5 for this missing side. How'd you do? Did you get it right? Hopefully. Moving on, we're going to solve the right triangle again. Round the sides to 2 decimal places and the angle to the 10th degree place. So why don't we find, let's try to find A first. So what would we do? Once again, Pythagorean Theorem. Okay, this should have a right angle in the corner. I don't know why. But it's missing. So what do we have here? We have 10 squared plus x squared equals 15 squared, because this side is the hypotenuse. 100 plus x squared is equal to 225 minus the 100 over x squared is equal to 125, and root it, and you get 25 and 5, so you get 5 root 5 for the missing side. To find the missing angles, which is A and C this time, so we're looking at, if we went from A, this would be the opposite side, adjacent side, hypotenuse. So let's look at doing the A and the H. So that's the cosine of angle A is equal to 10 over 15. So we do inverse cosine, 10 divided by 15. If you do inverse cosine, 10 divided 15, close the parentheses, you should see 48.2. Then take your 180 minus 90 minus 48.2, and you're left over with 41.8 degrees for the other angle. Okay? Now we're going to get into the story question. This is the real-life application, and you have to make sense of problem and try and persevere in solving them. So the angle of elevation is formed by a horizontal line from the observer's line of sight, looking above. And an angle of depression is formed by a horizontal line from the observer looking below. So basically what I'm saying is if you had somebody and they were looking, okay, they have a person here, and here's their line of sight horizontally, their vision of what they can see up here, this is the angle of elevation. Below that, this is the angle of depression down here. Putting together, that's the area, all the area that you can end up seeing. So that part kind of has to make sense to you for you to be able to move on. To answer the following word problems, you're going to draw, label picture, set up the equation, and you're going to solve for the missing information. Once again, round to the 2 decimal places for sides and to the nearest tenth for angles. So it says a safety warning for a ladder says the ladder at an angle of 75 degrees with the ground. Okay, so let's draw a building. Okay. Okay. We have a ladder. It says with the ground. So we have 75 degrees down here with the ground. You can see here's my right triangle because this isn't the Leaning Tower Pisa. This is a building that's erect and it's going vertically up. How far away from the wall would the base of the ladder rest if the ladder rested 25 feet up the wall? So we know that this side right here is 25 feet up the wall. We know this, and we're looking for how far away from the ground this is going to be. So this is where your trig comes in, and once again we'll write it out. So so the right triangle there for sum of 75. This is the opposite hypotenuse and the adjacent side. So we have the O and the A. O and the A, so we're looking at tangent. So tangent of 75 is equal to 25 over x. If you remember, what did I tell you to do to solve this? The variable's down here. I can't just bring the x over. So I said these two things should interchange. So take x is going to equal 25 divided by the tangent of 75. Pull out your calculator. 25 divided by tangent 75. Enter. Round to 2 decimal places. 6.6. Oh, this 8 turns this up. So 6.70 feet from the base of the wall. Addressing the question that they were asking, how far from the wall? There it is. All right, wrapping up 2 left. So this one, the length of a loading ramp is 15 feet and its height is 3 feet. So the length of a loading ramp. So we have a ramp. The length of it is 15 feet. The height of it is 3 feet. Find the angle of elevation. So what are we looking for? This guy right here. We'll call it x. So bring back your trig functions. Here's the O because it's opposite. H, A. So what do we have? We have the O and the H. So O and the H. There it is. O and H looks like the sine. So we get the sine of x is equal to O, which is 3, and H, which is 15. Remember how to solve this. This is where you have to do the inverse trig function, 3 divided by 15. So we go second sine, so the inverse, 3 divided by 15. Enter. Approximately 11.54 degrees is the angle of elevation. Okay. And last but not least, it says a ramp to a parking garage is built with a ramp angle of 25 degrees. So we got the ramp built with 25 degrees. Okay. The end of the ramp is 35 feet from the base of the garage. So the end of it is 35 feet from the base of this is the garage. What is the length of the inclined surface of the ramp? So we need to know how long is that ramp itself, not how high up it goes. So if we pull out our information, this is the O, this is the H, here is the A. So what do we have? We have the A and the H. And if we scroll back up, A and the H is right here. It looks like the cosine. So we're going to do the cosine of the 25 degrees is equal to the A and the H, which is X. I told you when the variable's in the denominator, flip-flop these, so X is equal to 35 divided by the cosine of 25 degrees. Calculator out. Second, so we do 35 divided by cosine, 35 divided by cosine of 25, and approximately 38.62 feet. Is the length of the ramp. Okay. Well, good luck on the assignments that go with this, and that you're almost finished with the unit because you have one left.